All right, welcome to this little session about accelerating domain-driven design with AI. So, yeah, nice to see. Seems to be an interesting topic. How many of you have read this book or know what it's about? Okay, good. Maybe a little bit less than half, I would say. So, what is, I will still go over a little bit, what is domain-driven design, or DDD, as they say it. So, first of all, it's the title of this classic book from 2003 by Eric Evans. And as the title say, it's tackling complexity in the heart of software. And by some people are seen as maybe one of the greatest books ever written about software architecture. So what is it about? If you stay a little bit at the title, and with domain, when Eric says domain, he primarily talks about business domains. So if you look at the examples from the book, it's, for example, business domains such as logistics, cargo shipping, banking, accounting, finance systems, manufacturing, production planning, and so on. But it can also be like retail, software, or service business. So the book is about designing software for these kinds of business domains. Often large organizations, but not only large organizations. Today you will find also small organizations that have almost similar kind of software that large organizations have. And usually these kind of applications are referred to with names such as information systems, enterprise software, or business applications. So are there some areas where you should not use domain-driven design? And if you ask Eric himself, he will say that DDD typically adds most value when the complexity is in the domain rather than pure technical complexity. So, for example, if DDD will bring maybe less value if the domain is simple. So, for example, if the problem is very easy to express and very difficult to misunderstand, let's say we tell a developer, take this algorithm and go and make it 50% more effective. That would be a quite very clear and easy requirement that the developer can go and develop pretty much in isolation. The developer doesn't need to talk to a long line of stakeholders to understand what is the requirement about here. So now we're talking about more pure technical complexity. So DDD would bring more value when you have a system with some kind of processes, work processes, where you have many actors, maybe many stakeholders that interact with the system in different ways. So imagine like a hospital, a system that runs a complete hospital with staff, you have patients, you have treatments, medications, you have emergencies, everything. So that is the kind of complexity we usually tackle with these methods and these concepts. Yeah, so that was just a little bit about DDD background. So let's dive a little bit more into the problem space, like with complex systems. Understand more the challenges with complex systems. And then we come back up and see if we can apply DDD together with some related techniques to solve these problems. So if you look at the definition of a complex system, I mean, a complex system is a term that is used in disciplines like systems theory, complexity science, of course, that's in software engineering, basically. When I ask AI to give me a simple definition, like a short definition of what is a complex system, it came up with this. So a complex system is one where many simple elements interact in ways that produce unexpected outcomes. So each element can be simple, but the interactions make the system unpredictable. So this hospital, for example. So we have many actors, we have many stakeholders, and they work together to solve some kind of task. I mean, some shared goal that they have, like keep this thing running, keep it working. But each actor or each stakeholder can have different subtasks in this. They share some information is not shared. And the behavior of all these actors cannot be fully predicted. These are usually humans. And when you put a lot of these actors that you cannot fully predict into in the same system, the number of edge cases will increase dramatically, right? It will increase exponentially. And the outcome really, really cannot be predicted. So when we are trying to design systems for complex domains, as if this problem was not enough, like we have all this infinite number of unpredictable outcomes, there's another practical problem that we will face in any larger or mid-sized organization that usually will throw our projects off track very quickly if you don't tackle this problem in the exact right way. And these are the silos. And I'm not saying that silos is good or bad. Silos are usually there for a reason. Some people say, oh, we should break down the silos. I don't say we should break down the silos, but we need to handle them in the right way. And like one example, my own example, maybe this was way back, example to explain the problem here. Maybe more than 15 years ago, I was still young and motivated, ambitious young consultant. I came into a medium-sized company they wanted to implement a CRM tool. So it was somewhere in middle of Sweden, north from here, and they had like a more traditional construction company. So they had a sales department that sold projects. They had accounting that sent the invoices, all different kinds of setups. Sometimes you invoiced a part up front. Sometimes you had a leasing, you had rental invoices, and all kinds of setups. Anything that the sales people could come up with just to sell the projects. Which usually is the case. And then you had the project management or the delivery organization that has had to deliver those projects. So I went all in and said, okay, I'm going to make this a really great project. I did my deep interviews with the sales, with accounting and project management. I wrote everything down. And long story short, we implemented according to the requirements I had captured, and the project failed. So why did it fail? So the reason it failed was that the silos were not aligned. The handoffs between the silos always failed. So when you started looking into those sections where they hand over information between silos, you would see things like the sales sent an email to accounting and said, invoice this customer. Soon an email came back. We don't have the invoice address. Our sales would send an email to project management and say, okay, when is this project going to start? And they would say, well, we don't have a start date. And by the way, the customer is not in the system. So all these kind of things, the silos were not aligned. The handoffs always failed. So the requirements were not ready to be translated into software. So regardless of how well I would have done those interviews, then like the pieces of the puzzle didn't fit. So in this landscape that we have with all these challenges, maybe it's not so strange that research consistently shows that 50 to 70% of large enterprise software projects fail to meet the goals, with severe overruns and value shortfalls common. And I just read, I think yesterday, or maybe this was on Monday, that another 5 billion is going down the drain. This is in Sweden. They built a journaling system for healthcare, and now they are thinking about getting rid of the system, and it never really launched. All right, so we have a challenge. We have a substantial challenge. And how do we solve this? Can we solve this? And what I will try to show today is that the answer is yes, we can do this. There are ways to show this. There are practical, quite easy way to tackle this kind of project and make them successful. And it's actually not even difficult when you know how to do it. So there are a couple of keys to unlock this. So the first thing is, if you go back to the definition here of a complex system, it says many simple elements interact. So actually there are some simple elements here. So that looks promising. So if we can use that each step in the system is not complex. It's quite simple interactions. Usually, basically, we're just shuffling information from left to right in some kind of information pipeline. And if we can just identify these simple steps, that's a good start. And there's another thing we have to see, that we can never solve all the edge cases in a complex system. But luckily, we don't need to do that. We just need to find the few main scenarios that bring, let's say, 80% of the value, and solve the most dangerous edge cases that can risk to destroy all the value we built up. And if we just can effectively figure out which are these most valuable outcomes that we want to achieve, and then we can there's always going to be some edge cases that we need to handle ad hoc. We just need to make sure that those edge cases that won't bring down the system, and then we'll be fine. And the final thing we need to identify those simple steps. We need to find those most valuable paths through this complex organization. And then we need, if we can find an effective way to align the silos. So not necessarily destroy the silos, but align them. So when we translate the requirements into code, it will just work. So if we can do these three things, I think we will be quite good. So the solution here is that I will talk about today is a combination of a couple of selected methods in the DDD family, you can say. So it's domain-driven design. It's combined with event storming and also data modeling. So first we need a couple of building blocks from DDD. So I will not explain all these building blocks in detail, just on a high level. So DDD gives us these like Lego building blocks that we can use. And it will help us to know what we are looking for and help us to recognize these things when we see them. And one important concept is the domain language. And what it tells us is we need to, when we talk to organizations and we talk to stakeholders and domain experts, we need to listen to the terminology they use when they talk about their organization, when they talk about their processes, and really carefully listen to exact, like how do they name the information objects. Then we will use the key building blocks like bounded context, Basically, it's like subsystems. Domain events that we will talk much more about. Entities, we have aggregates, we have value objects, and commands and queries also. So these are our pieces that we use when we're building our building blocks. So that's what I mean. We're building models here, just like I mean, what is a model? That's maybe very obvious, but yeah, let's say when they built the pyramids thousands of years ago, they probably had a little smaller pyramid built first that they looked at as a blueprint. So that's what we are doing. We are building these kind of models of that later will become our system. So those are the building blocks. So now, but how can we now go ahead and find those valuable paths and align the silos? And this is where event storming comes into the picture. So event storming gives us the tool to help us to collaborate with stakeholders. It's a workshop format where we bring together multiple stakeholders across silos. You can be 10 or 20 persons in the room or in a digital tool at the same time, and we're mapping domain events on a timeline, basically. And it will naturally help us to find those most valuable paths that we want, like the flows that we want to happen. And it will also help us to naturally align the silos. So key domain event is a very important concept here, and it's we are trying to identify events. So events are things that happen at a specific point in time. They usually in event storming, we just use orange sticky notes. The rule is that it's a verb always in past tense. That turns it into make sure this is an event. So you can ask, did it happen, or when did it happen? So you should always be able to ask that, and it has to be relevant for the domain experts. So domain events can be triggered for different reasons, like a user action. Usually it's a user action. It can be triggered by an external system. It can be a result of just time passing, or triggered by another event. And then, in order to define those smallest steps, those simple steps, the information pipeline, that each step in the workflow will have some input and output information. We will do a simple data modeling, which is capturing the entities and the aggregates. So the entities, and we have the aggregates, we have the commands, and we have the queries. So I will show you a practical example of this. And I will use a tool that we develop at Clarify. You can do similar. You can do this in similar tools. You can use Miro is a very popular tool to use this. And I will just take a simple example. So let's say that you're coming into a new project. You're coming into a company, and you need to fix the recruitment process. They have a problem with the recruitment process. This is your job. This is what you need to fix. And we will use AI to give you a quick start. You don't need to use AI, but you can use AI. You can save a lot of time by using AI, both if you have no idea what is this process. It's a completely new green field, that we don't have any recruitment process. Or if you already have the steps very well lined up, you can still use AI. So let's see if I can show you an example. Okay, I will mirror the displays. Okay. So let's say I will start by getting the help of AI to fast forward the event storming part. We can say, for example, let's use a recruitment process for engineers used by Google. Maybe that's a simple start. So now what we do is we go to a selected LLM. In this case, we're using Gemini 2.5 Flash. And we start by we're asking for all these building blocks. We start by asking for domain events, put them on a timeline. We ask for the actors and put them as swim lanes. And then on each domain event, we identify what is the command here. Because, okay, I will just do like this. Maybe it's a little bit slow. I can switch over to here. So what we're getting here is we're getting the actors on swim lanes. So here we have, for example, the hiring manager, we have the applicant, we have a recruiter, we have an interviewer, and we have a hiring committee and the HR admin. So these are all the actors involved. Then we initially place all the domain events on a single timeline. That will help us to model like the most valuable path. We start by focusing how do we want this process to look like. Then we can go ahead and we can model basically any number of edge cases or variations of the flow. We can model those things. But first of all, we should focus on what is the most valuable flow. And this happens quite naturally because with the events on the timeline, it becomes a story. You can read it as a story. So once you have this storyline, okay, I will just remove these ones. The second thing that you get when you're working with this way, you're visualizing each actor, you're visualizing the steps, is that you get the tool to align across silos because everyone can see their own role. The hiring manager, or what do we have here? The hiring committee down here, they can see where they come into the process and they can see all the steps that happened before. So for example, in this construction company, if we were modeling this, the project department, they could easily see that, okay, what are the sales guys doing over here in the beginning? What are the events that are happening? What are the information objects? What are that you're updating? And they can say, okay, why don't we capture the VAT number of the business already in the first phase? And the salespeople might say yes, or they might say no, we don't know this. Don't give this to the salespeople. It's not going to work out. And that's the conversation that is the most important thing to have, because when this conversation starts to happen, then naturally silos it will be very visible where those silos are not aligned. And if people have good intentions, they will find ways to align. So here we both get a push to work with the most valuable path, and we get to align across the silos. And the next thing we can do is we can go one level down and say that, okay, each little step here is now gets connected. It's a little bit difficult to see. Each step of the process should be the smallest step. It should be one command done on one aggregate, as they call it in DDD. So this means basically the smallest consistent update. The smallest update you do to the system, respecting all the business rules and business logic. So for example, if you have something like every month we have an automatic routine that is We have subscriptions, and we create orders, and we create shipments, and we capture the money. So that's not one step, that's 3 or 4 steps, because it's multiple aggregates that are involved. So each step has been limited to this one command. But it can also have, every step becomes a contract. It has queries. It can have more than one query. So here we can see that we have a recruiter. And the job in this case for the recruiter is trying to make it bigger. The job of the recruiter is to screen an application. And the result of this is the recruiter is only going to add 2 things. It's going to add screening notes and the screening result. And the input is going to be the applicant and the application. And here are the fields. So the AI has generated this for us. This has suggested all of these things you see has been created by the AI. And it will give example data as well. So you can see I can work through examples here. So every little step of the process is now specified as a contract with input and output. So now the last step of this. So basically we've used AI here to really speed up the process of creating a domain model. This is a domain model. The last step that we haven't that is missing now is putting these entities into bounded contexts, because all these processes, they will span across multiple systems. In any large company, you can have 10 or hundreds of different systems. So this kind of process will usually span over many systems. And what we do then is we assign the entities into bounded context. So here, for example, we can see that the job posting here is in LinkedIn. But we have the HR system that holds the applicant and the application. That's in the HR system. And then we have other information objects that are not yet received the home to where they can be. So this is the domain model. And of course now we can So what can we do today when we have a domain model? When we have the workflow, we have the entities, we have the aggregates, we have queries, we have commands. What can we do then? Well, it wouldn't be, given that services like Lovable, for example, they can build these kind of systems almost without anything. Imagine how much more you have now. When you have a domain model that you can give to the AI. And so what this can be, what we can do with this is a contract specification. This can be turned straight into, for example, an open API specification. So the commands are the endpoints. These are the parameters of the commands, and these are the aggregates of the information objects that we update. So we can turn this now into an API specification, for example, using Swagger format or async API. And we can give it to your AI tools to build. I mean, you can get it through MCP. if you are using Claude Code or Cursor, and you just build your system based on this. Or we can also generate it here. And because we have a domain model, we can generate the whole application in parallel, because every part has its contract. This has defined input and defined output. So these different commands, they don't depend on each other. Everything just depends on the domain model. So we can build the whole application here in parallel. Doesn't matter how large it is. But it's still going to take a few minutes. I can go over here. Yeah.
How did the AI learn about the domain? Or was it just your prompt?
I don't know. It just knows a lot of stuff. I mean, this is generic, as you can see here. This is maybe we have a couple of options here, like Gemini Pro, ChatGPT 5. So I guess it's just so much information out there about these kind of projects. And you can pick up from code projects, you can pick up from documentation and manuals. So you will find that it knows pretty much any, like it has a lot of the domain expertise in itself. And of course, you could train it, you can fine tune it and train it with even more to make it even better. So once you have this, let's see. So what we get now is that each command can have its own prompt, like register applicant. This is the prompt for registering, for generating code for this endpoint. You can customize it. This is the entities that we are generating. I didn't mention given when thence. You can connect to each step. You connect given when thence that will be turned into test cases. And those given when thence are the key also to make a system that is robust to handle all those edge cases. So you, in each step of the process, you make sure to describe what success looks like. So for example, here, this process step interviewer will submit phone screen interview feedback. Given a phone screen has been completed by the interviewer, when the interviewer submits their feedback to the phone screen, and so on. So each step can be described what the success looks like in order to move on in the process, basically. Yeah, and it turns out that when you have this kind of domain model as a basis, code generation is much more likely to succeed. Let's see if this works, because it's the scope for the code generation is so limited. It's not allowed to touch any other files. Like if you do changes now to a certain endpoint, you regenerate only that part of the code. The AI is not allowed to touch any other parts of the code.
So is there a round trip? As in if you change the code, does it change the model?
Yes, exactly. So I can show you this. For example, if you look at the, so it must be really hard for you to see this. let's say you have this command, or you register application, register applicant registered. I guess it's this one, register applicant, yes. Okay. So let's remove a field here. LinkedIn profile. We don't want LinkedIn profile here when we register applicant. So we delete this. Now, when we go to the code view, let's see. Oh, sorry. Wrong place. Let's remove something else here. Contact phone. I will remove this one. Oops, sorry. Stop generating. Oh, sorry, I pressed the wrong button. But what happens here is that because the API specification is version handled, it will just know exactly which part that was changed. Yeah, so that's basically what we can do. So you have this kind of challenges. You have a complex domain. You need to align the actors. You need to align them around the process. You need to align the silos. You need to find the most valuable flows. And then once you find them, you want to go down and in detail say what are the input and output of each step in this process. And each step will then be connected to queries and commands. Commands will be connected to information objects or aggregates that you update. And once you have completed this, you can basically go ahead and you can generate the whole system, which also gives you extremely fast iteration time to iterate together with stakeholders and validate your assumptions. So yeah, that was basically it. Is there any? Are we ending now? Is time up? Anyone with the schedule? I think it was 40 minutes. 5 minutes. Okay. Any questions or comments? Yeah.
I guess once this has been executed, you get some kind of abstract repository or something like this?
Yes. Yes.
And after that, where lies the truth? If you're removing a field from source code, will this model be updated, or do you need to change it here?
Yeah. Yeah, I mean, that's up to you. So what you can do here is basically you can delete this, you can regenerate it from the source code. So if you want to go ahead and just work with the source code and then have this as an after the fact documentation, you can work like that. But what we see now, a lot of people are most interested in is to have a domain model like this, and then use MCP server and connect with, for example, Cloud Code, to just have access to this whole domain model, and then use their own set of tools to build the systems. And then you can update the domain model in the tool here, or you can also use the MCP to push back updates to this tool. Yeah, other questions? Okay. Great. Okay, one more. Yeah, so usually what we do is, in many cases, we start with a blank sheet like this, and you just model something very quickly together. Maybe you have a process went wrong. So you say, okay, why did this process go wrong? So you can move stuff around and say, okay, so we have a problem here, a shipment, we shipped wrong product to the customer. So why did we do this? What are the different actors? And you do this a couple of times, like pure simple event storming that you would do on a whiteboard. You do this a couple of times and then you start to understand the problem space, the problem, and then you can maybe create one that is more like a to be. How do we want it to be in the future? So this is one way. Or it could be just like you generate it with AI, or yeah, there's many different options. Yeah. Anyway, I think we're out of time, but feel free to talk more if you're interested in this topic. I love to discuss much more about this. So yeah, thank you very much for attending.